things that have to do with technology, with society. Our dear friend of the school, Arturo Cabanas. Arturo, sorry that we're running so late. We had such an interesting couple of chats this morning, and really we were quite delayed because everybody was so interested. Don't worry. Arturo works in Amazon Web Services, which provides cloud services, and today he's going to be telling us about resilience in the cloud, challenges and benefits, something that raises a lot of interest. We still have an hour left. I'm sure that we're going to have lots of questions, so I do hope that we have time. Once again, I'm so sorry that we're running late, but these things happen. Thank you for being flexible. It's an honor to be here, and particularly to be able to talk to you about this subject. It's extraordinary to see how the community is growing year after year. So it's great to be here. Thank you for the opportunity. You know what? We got a prize from the WICES, from the International Telecommunications Union on Tuesday. We have been nominated on various occasions before, and 2 years ago we made it to the short list in 2022, the last 5. But this year we won the category for international cooperation, so we're delighted. And thanks to all of you who helped us with this program. It's not just the organizing team, but the students and the experts and the sponsors who help us to make this event such a success year after year. Well, I'm not surprised you won, but congratulations. Well, hello everybody. I think that you have my name up here. I'm Arturo Cabanas. I'm the head of security and compliance for Latin America, Canada, and the Caribbean for Amazon Web Services. Today, I'm going to be talking about something that could be quite complex. I've seen some talks that have ended up being very complex. But so my idea is to talk about these concepts that I think is very important that everybody understand them and be able to understand them easily through examples which I hope can be of practical use to you. The idea is that by the end of the presentation, you'll be able to understand what it means to be resilient in general, what it is to be resilient in the cloud, what are the challenges and benefits that we can reap. Let's start with something more technical. I'm going to try and translate this in a way that you can understand. So, first of all, let's define what a cloud is. Here, I'm going to tell you what it is. There are different definitions, but the most simple one is one here. It's a way of executing applications, networks, and other resources like AI, which is on everybody's lips, without having to manage a data center. And it's got to be a utility service. It's like electricity. When you connect something, you get electricity. When you plug it in, you have electricity. When you unplug it, we don't. By the way, we have simultaneous translation. So please, could you talk just a tiny bit more slowly? Sorry to interrupt. No problem. Oh, sorry, I do tend to speak fast when I get carried away. There's another way of understanding what cloud services are, and this is by comparing them. If we compare the services of a traditional data center to those provided in the cloud, let's look at the picture on the left when it says traditional infrastructure. Data centers, which you can see near those cities. When you use these services, you have to acquire the right equipment, like servers. These servers require initial investment It's never under $5,000. They can be as much as 100,000. You need people who know how to operate it with long-term contracts for maintenance purposes. If you remember, I said that web services can be utilities like electricity, and this example, you can see that when you use web services, you don't pay up front. You just pay for it when you don't just pay for it when you use it. It's like a monthly bill. It can be escalated up or down. If you need more service or more space or more capacity to store your AI services, then you are going to see it expanding or contracting according to your needs. There are many other definitions, but I try to keep it as simple as possible. Let's move on. Resiliency. What is resilience? When it's operational, when it's in the cloud, there are lots of definitions. What I've tried to pare it down to is the most common definition. It's basically the capability to withstand or recover from an interruption. How can we limit or delimit the fact that our application or service, how can we prevent it from being interrupted? For example, if internet falls or you have a power cut, or if there's an error, or if there's a hacker's attack, how can you ensure that it continues to provide services? That's what resilience is about. On the left, we can see what could happen in specific cases for the financial sector if we don't take resiliency into account. We want to be in the little green circle, normal operational situation. But this could be in a platform where clients can make or receive payments. But if we don't take resilience into account, our problems will snowball, as this could have an impact on our clients, on our business units, and even on the financial sector as a whole, which is a big deal. The problem we have is that everything breaks down all the time. We need to build systems that take errors as something natural. It's not whether it's going to happen or not, it's when it's going to happen. And on that premise, I want to bring two examples to the table. Let's look at a hypothetical case. This is Juan. He's just been hired. This could be you in the future. He's going to be responsible for creating an infrastructure for a new bank. It's just developing its services, and it wants to use the cloud. And we're going to launch an app to make and receive payments, and we want it to be very resilient. We want our clients to feel secure, to be able to sleep soundly at night. We want to make sure that whatever happens, the clients will not be affected. So I'm going to tell you about this hypothetical case of what Juan would do. But the first thing he's going to ask himself is, how do I build a resilient system? How do I do it? Where do I build it? Will it be enough? So the first thing is, what happens if I use my own means to build it? If I build my own data centers? This was very common in the 80s, 90s, and the beginning of the noughties. But this is a hypothetical case. So let's imagine that Juan is going to go down this road. The first thing that tends to happen, or tended to happen, when somebody built a resilient data center architecture was to choose the locations, because we need two data centers, one to serve as a backup if the first one goes down. So then the first thing you need to do is to have a construction when you build these two data centers at various kilometers distance from each other, because there might be an earthquake or a hurricane, and we don't want them both to go down at the same time. And then we would build these two different data centers in these two locations, and they are probably going to be connected by fiber optics cable, so that if one goes down, the other can simply slip into place. So one starts to build this. Now, in each data center, I'm going to place servers and databases, which are going to store the information, and servers, which will process the information. They are replicas of each other. Now, as it's built, this will enable one to have exactly the same information available at exactly the same time in both data centers. Because as soon as a piece of data goes into one, it'll go into the other. The point being that if you lose one piece of data in one data center, it'll be available in the other. With this, how can this architecture be communicate with the end user? This is very simple. The consumer is the end client, and he says, I want to pay money to my mum. They don't need to worry about what's going on behind it. But for Juan, he needs to know that the consumer is going to use the application, is going to request that a payment be made. And this request goes through the DNS. The DNS says, this goes to data center 1, which is receiving the information. Data center 1 answers it, and consumer sends the money to their mum. Not terribly complicated. But things may happen. As our CTO says, what happens if there's a fire or flooding or power outage and the data center that Juan built goes down? Well, Juan had the foresight to build two data centers. So what's going to happen is that this DNS, instead of sending the information to this data center which has gone down, sends it to the secondary one, the backup one. And as you remember, I said that the information is stored almost simultaneously in both data centers. So the data center is perfectly capable of responding to the consumer. The consumer would never know that there was a problem with data center number 1. Great so far. And this was considered to be a good practice through the 70s, 80s, 90s, and the beginning of the noughties. But as you know, the banking system is highly regulated, which could have implications for Juan. And the system is often audit. And that's fine, because it's got to be as safe as possible. So the auditor says this architecture, this is the technological and architectural system you're using, and you may not know it. I don't know if you can see this. What you have, one, you could, on an average, have your system down maybe as many as 7 or 8 hours a year. So for 7 or 8 hours a year, his clients would not be able to access the information. And that's really serious. That's 7 or 8 hours, which can cause problems for the bank's reputation. They'll get complaints. They could lose clients. They will get ticked off by the regulator. And what's worse, it could even lead to their clients having problems. And that entails a whole series, a whole raft of responsibilities. And that's something that maybe Juan hadn't taken into account. So perhaps let's look at what Juan could have done if he had decided to use cloud services. As you may remember, he started like this. We're going to have two data centers, which are going to be some distance apart, so that we can be sure that if something happens with one, it won't affect the other. With cloud services suppliers, what we do is go a little beyond this plan. First thing that we do, at these distances that we have, we'll set up similar data centers which are close by. So suddenly it's no longer two data centers, but four. Beyond that, we're going to create a third layer. We're also with two data centers. And this network of data centers are going to be connected with fiber optics, which enables communication in microsenders so that all the information is stored everywhere. And we also connect them between each other so that if one goes down, the other data centers are immediately able to communicate with each other and information is never lost. Each of these data center combinations, as you can see in this little square, we call availability zones. The regions of AWS services contain an average of 3 availability zones. And each availability zone has 2 data centers. That's a region. And why is this different to what Juan did? He had 2 data centers, and suddenly we have 6. But we have 6 that are interconnected, so they can store information synchronously. The distance between these availability zones is at least 60 miles or 100 kilometers to ensure that there are no events, natural events like earthquakes, which could affect more than one at the same time. Now, going back to Juan, what we have, unlike what Juan has, is a highly resilient architecture where the location of each zone is independent of the other, independent of power and air conditioning units. They're completely different geological areas and so on and so forth. In the world, if we look at the world and we can see our global infrastructure, we have 33 regions like this. You can see that the orange colors, which are the 33 that we have at the moment, and the red ones, like this one in Mexico, are regions which are currently under construction and will be up and running in the near future. These 33 regions are made up of 105 availability zones. So this is a region, right? It's divided into availability zones. So our 33 regions are divided up into 105 availability zones. This is a resilient architecture. This enables clients who use important computing services to have access to very high tolerance to failures, to errors, and high availability. So let's see what would happen if Juan had gone for this solution. I've already explained the difference in terms of architecture. Now let's see what Juan would do. So Juan, if he were using these cloud services as shown on the screen, instead of using the 2 data centers, he would have 3 available, and this information would be stored in the 3 availability zones. It means that there are lots of services going to be there. And it's very important to know this. And it's not just Amazon that's doing this, the competition is doing this as well. But you need to understand how you can build highly resilient architectures. So these suppliers work at a scale whereby we can use databases to communicate with each other and do so smartly and be able to know that, for instance, this server has a problem, so we're going to use another one. This server is overwhelmed, so I'm going to use another one. This particular service isn't working, so I'm going to lower usage. This all means that at the end of the day, Juan is only using what he needs, just like with your electricity. So this keeps costs down for him. And it means that he's not paying for capacity he's not using. These services work like this. Usually what happens is that the communication between the consumer or the clients happens in the following way. The consumer makes a request, say a transfer to their mum using the DNS. And the DNS, when you, for instance, write in Chrome or Firefox or Facebook, what the DNS does is translate that into an IP address, which is unique to the server. So that means that we know exactly what the IP address is. The DNS helps us to translate a physical address into an IP, which is and then knows how to send it to the server. This information is then sent to Juan's bank and translated into the IP there. So the DNS selects this golden line and this availability zone, and this availability zone is the one that's going to respond. Now, why does it choose that one? The DNS looked at the first availability zone and then took a decision automatically using requirements that Juan may have already established. He may say that all the first requests should be sent to the first availability zone. Or perhaps it should use another one. Or perhaps he can choose an availability zone which is being underused. So here we have availability zone 3, and he chose it maybe because it was being underused. Juan's not actually taking the decision, but he will have understood what's going on. The system responds, and to make it completely transparent, Juan can see which one of the zones answered the request. This architecture is what enables banks and Netflix, for instance, to have really high availability. When was the last time you turned on Netflix and saw it didn't work? Well, it's ages ago, right? Because it uses this kind of infrastructure. If you look at this in technological terms, you may remember that to achieve high resilience and high availability, you need an architecture that works with at least three availability zones that are interconnected. So one can easily create this. He doesn't have to have any special technical know-how. He can codify the creation of all of this process in this way. He didn't have to build a new data center. He didn't have to buy any servers or databases. It's highly scalable, which means that the server can grow or shrink according to the number of users or consumers that the bank has. If suddenly there's a big number of payments, it can accommodate that. As the architecture can scale up and it will create more space to store data so that it can answer just as quickly to whatever consumer request there may be. Let's have a look at another detail. I've nearly finished. Now, what would happen if one of these zones went down? One of the regions went down. What would happen then? Well, what you need to know is that all the architecture, this infrastructure and services are generated with code. One doesn't have to ring somebody up and say, please transfer me to another server. And we'll say, please, I'm having some problems. Can you help me sort this out? There is a programmer who helps one to create the structure. So the programmer automates the creation of these servers and databases. So when a request comes in from a consumer and he realizes there is a problem in one availability zone, he'll automatically avoid it. If you remember the original architecture, and it will go to another one. But it will also, because the servers are in the first availability zone, already have their capability of being turned off because there's a problem. There'll be a fire. Whatever happens, it's gone down. But because it's just code or text, this service here creates more servers in case there is another problem and uses the third one to create a new server automatically. One doesn't need to do that. It happens in seconds. But the decision was taken when they developed it. So, if two availability zones go down, it means that the third one won't go down because it can't cope. It's already had extra structure built into it to be able to enable it to withstand the extra demand. Maybe the power comes back and the availability zone comes back online. And so the extra servers are disconnected and we go back to business as usual. So Juan has an incredibly resilient architecture. This is something that can be programmed using software. It can be set up in a question of seconds. We don't need to request extra services each time. And probably the most important thing is that Juan has the flexibility to create architecture to suit his needs. Now, this architecture here is made for clients who need to have very high operational resilience, like, for instance, a hospital or video streamers like Netflix. They also need very high availability. But perhaps you end up working in companies that don't need such high availability to use this kind of infrastructure. And this is another benefit because it's completely optional. It's programmatic. One could say that for cost reasons, I don't want to use the 3 availability zones because he only wants to use one. So that cuts costs. But if suddenly his business grows exponentially and it's vital to keep the operation running, so he can simply scale up. All he has to do is modify a couple of lines of code, and he'll have the 3 availability zones available and an unlimited number of servers. Let me give you another example. One of the bodies that carries out electoral processes, they had an annual budget of $15 billion to maintain an infrastructure used every so and so years when they have elections. It was just set up specifically for this. They bought it, and they had to keep organizing things in the same way. It was a tremendous outlay. So when they held the elections using the services for the first time, the first thing we recommended was an architecture similar to the one that you're saying, because we knew that it is normal that you get lots of attacks, and that if anything happened to something as important as maintaining democracy through elections, then they needed to be protected. So we built an infrastructure rather like this one. The elections were held without any problem, and they got over 400,000 cyber attacks. And just so you know, those elections cost $60,000 versus $5,000 they are spending a year to maintain that infrastructure. And that's a real example of people who are using this infrastructure. And I insist, works for countries where they've implemented this. This has really helped to save costs and safeguarded the conditions for them to carry out free and fair elections. There are lots of different examples of clients who have launched new projects, and thanks to this structure, they've been able to save millions in annual budgets. So I'll wind up here. Let's see, anybody in the audience has a question? I've tried to make this as easy as possible to understand and not get too technical, but I'd be delighted to go back and explain something if it wasn't clear. Okay, a round of applause, please, for Arturo. Thank you. Questions for Arturo? Now, we don't have much time. Thank you, Arturo, for the presentation. Maria Fernanda from Colombia. In the case of Microsoft, some governments and defense authorities have certain requirements when it comes to sovereignty in certain regions. Yes, this is an issue that's very important in sovereign nations. This has to do with regulations, but we need to separate this into two. One is the need to have a sovereign treatment of information, and we also need to have infrastructure in that country. Countries like France, who have most requested these kinds of services, have required infrastructure to be built in the country, and they have sovereign access. The examples that I've given you, well, in these regions, our clients can have sovereign access, which means that clients at all times are the owners of the information. Nobody else have access to the data, and they can decide what to do with them. And that's very important because we need to comply with a lot of regulations around the world. Just in Latin America, per country, they have personal data protection law, data security, cyber security. And most of these countries, we are prohibited from acting as suppliers, from having ownership of the information. There's a contractual issue, and we also have to comply with the standards. So we have to guarantee to these clients that only the owners of the information can access the data. The other thing is having the infrastructure in the country. This is divided into two ways. In France, they're trying to drive a local economy. So what we're doing is create sovereign access servers in Europe. It has been shown that it's not true that this actually enhances the local economy. In fact, it may be the way around. Local economy, when it is obliged to acquire services only in its country, cannot access the most innovative technology. If, for example, we take a country and as an example, and it obliges its suppliers just to use its own AI systems, they would have no access to international ones. They would be unable to compete with other companies that don't have this problem. So it's a globalized issue. The other issue is that it doesn't mean that this is safer. Information security doesn't have anything to do with its location. You want to ensure that who is providing the information has the best conditions. It's got nothing to do with whether they're in the country themselves. So we're talking about data sovereignty and sovereign access. And the other thing is having the data limited to a definitive country. And we've seen how in Brazil, for instance, this has really had a negative impact on the local economy because it has enabled them to access more competitive services. I'm Marcia from Bolivia. If I were to use S2 and S3 and wanted to make questions about large quantities of data, would I have a limited amount of time to ask the question, or would there be a limit on the amount of data? The issue is what is meant by unlimited. You can build and replicate your S2 and S3 services in an unlimited way. There is obviously a physical limit on this, but even our largest clients, as in Capital Mark I in the United States, which is an insurance brokers, they use thousands of servers, and the quantity of data goes up and down. They create S1, S2, and S3 constantly every minute. there are certain things that have to be taken into account, which involve costs. If if you're going to use that quantity, what's the best thing for you? Sometimes it's best to grow vertically rather than horizontally. Maybe we need a bigger server, and so we're talking about an S3, which would help us to store more information. Now, unlimited as such, no one can really say what that means, but honestly, at the end of the day, there is no limit on the amount of data you need to create. Carlos Ramirez from Mexico. Could you talk a little bit about the interoperability between the different clouds? I think that different clouds offer very similar services. But what happens when I want to exit one cloud and go into another one? For instance, I'd like to know what happens. Obviously, not with AWS, but what happens if you had the DRP of another client or another cloud? How do you reestablish services that are in another cloud? Like a disaster recovery program. Sometimes the official answer is not one I particularly like, because you, as the client, are responsible for using standard technology to enable you to use another cloud. Let me explain it another way. If you use containers, that's very easy way of migrating from one cloud to the other, because what you've got again inside is DNS. And AWS means that you can migrate anything in that sense, and you just stick it in the container, and if your other supplier is also using containers, then it's just as simple as that. The problem comes when clients start to build using different technologies with different applications, and the problem is that they're different, that you don't have the right ATIs, so it becomes very complex. And in the future, if they want to scale up or scale or move out, they don't know what to do. Let's see how we can create an applications architecture that uses standards that enable us in the future, if necessary, to migrate. But DRP specifically is a part of this business continuity plan, and within the plan, they should consider the possibility of migrating to another data center. So companies should never get to the point when it has a DRP without thinking about how they're going to migrate to another one in case of emergency. And the solution is that I, it's a technical issue basically, but basically the idea is to use technology that enables you to migrate and move around. For instance, function as a service, and Lambda was unable to do this at the time, but then it developed a new way of doing this, so it was able to migrate. But I don't think I think it's really about how you build your architecture and how you plan the future into this. Leandro Martinez from Peru. Congratulations for the way in which you explained something so simply, because actually the cloud infrastructure appears to be very complex. In my country, in Peru, We use the Red Nazi, which is the national Peruvian network, which is supported by a fiber optics network. It's operated by the government, by the Peruvian state. And as you can imagine, very often, states don't have either the capacity or the experience to operate a network of this kind, of this size. My question is it possible that a network of this size can migrate to the cloud? Is there an example that you can share with us of this happening? Thank you. Part of my work on a daily basis is to allow countries or help countries in Latin America to unblock the use of the cloud. I work with regulatory authorities, and those are the people who say what can and can't be done in order to to keep the different sectors healthy and safe. The main problem we have is that most regulations are very out of date. So it's not just a question of capacity. We could easily migrate to the cloud without any problem. The real problem is that the governments aren't at that level. And even if one institution might want this to happen, if the regulatory authorities aren't allowing this to happen, then it's not going to happen. This is a big part of my work, is to explain how this works to the different regulatory authorities. Yes, it can be done in principle, but the greatest problem has to do with the regulations in different countries. I could give you an example. There are lots, but this one is particularly interesting. The superintendency in Guatemala. 5 years ago, that was most of Central America was carrying out its digital structures at a local forms with their own programs. It was all very expensive, it was very fragmented, there was little availability, the networks tended to go down all the time. One advisor and 3 programmers in the superintendency contracted AWS, and we said we want to try this out. After several months, they developed something that even today is the backbone which it manages the entire infrastructure in Guatemala. And it wasn't too much, a few $1,000s. They carried out a tender to scale up, and it ended up creating lots of savings. There are lots of examples about when the regulation permits this and there is an interest on the part of the government and there is somebody that really wants to do this and has the experience, things can really happen and great savings can be achieved. Okay, Arturo. Round of applause for Arturo. Thank you very much. It's been a great pleasure to talk to you, and thank you for listening. Yes, I like the question of Peru. I agree with the comment about the way that you described everything so simply and very easy to understand. Thank you. And I'll use the material for my own classes. So greetings from us here in Argentina. And thank you to AWS for its support and for your time. Have a good day. See you soon. Thank you.
Is Sarah here? Not yet. Oh, we still have 5 minutes. I think we can break for 5 minutes. Before you leave, I would like to say something interesting. Sarah Armstrong is the director of or the CEO of the Internet Society Foundation. They have a lot of funding. Some of them, some of the funding is very important. Some of them are not that significant, but especially they place priority upon research. It could be researchers, individual researchers, NGOs. So if you see the requirements in the website, since they are based in the United States, I'm sure they have legal requisites and they may require a structure like 501 or special format of a non-for-profit organization, but I don't know how easy it would be for a Latin American organization to fulfill those requisites or those requirements. Funding is important for 1 or 2 year research project, or they may have shorter term research. That may be for doing research. Then Internet Society chapters also have funding for chapter members. If you want to become members of the Argentine chapter, you can join the chapter. For example, Adrian and I, are members of the Argentine chapter, and they're very active in also in Bolivia, Peru, and Brazil. So we're going to ask Sarah for these details. I was telling Sarah that she should be online at 1.